There's a plethora of data out there today about what service level objectives are. There's a lot of data out there and a lot of resources that you can read about what the various components of such an approach might look like and what their definitions are and things like that. But at the end of the day, service level objectives are just a way to gather data in a different way. And what I want to focus on here is what can you actually do with that data? So I want to start off with who I am. My name is Alex Hidalgo. I am currently the principal site reliability engineer at Noble 9, a startup focused entirely on service level objectives. So before we get into the real meat of the talk, which is about what you can do with your SLO data, let's first talk about why you need SLOs in the first place. Why do you need this particular kind of data? And it's because we live in a world of services. We live in a world where everything is now a service. We have things like platform as a service, or infrastructure as a service, or monitoring as a service, or network as a service, or database as a service. And none of those things even begin to approach our favorite acronym, which is SaaS, which in and of itself can stand for software as a service, or security as a service, or search as a service, or storage as a service. And even if you don't live in a world of as a services, you have likely adopted some kind of microservice architecture, which is a world where many different services exist and they all depend on each other. So you have services that depend on other services that depend on other services that depend on other services. So how do we get to this world? How do we get to a world where we're all dealing with services all day, all long, and they're all talking to each other, and we have to figure out how to measure them? Let's start with just telling a little startup story in a way. Let's imagine someone has come up with a great new web app, some kind of web-focused, user-oriented, like website or, even just a public-facing API. It doesn't really matter exactly what this is. The point is someone gets started and they write this new web app and they put it out there and it starts running, and then things get a little busier. So they realize it needs to be distributed. It can't just be a single instance of this app running. You need many instances of this app running. And once you have many instances of an application running, you need some kind of load balancing. Doesn't matter if this is, a hardware load balancer or just some kind of round robin DNS. If you have a distributed service, you need to make sure that the traffic is distributed across all these services in some way or another. And as things continue to scale, now you realize you need a separate database. You can't just rely on local storage anymore. And then as things get more advanced and some more people are hired at the startup, someone wants to write a new feature and they realize it'd probably be better to segment this off so you don't end up with a single monolith. So now you have a new service that this primary web app relies upon. And then someone adds another new service, and this one also has to talk to the primary database, and then some other services are added, and then the database itself has to be replicated because it's no longer going to be reliable and it's no longer be scalable if you just have a single instance of that. So now you have a bunch of databases, and then someone adds another new feature, and then you realize that they're actually all kind of interrelated. So it probably makes sense to put some kind of proxy in front of this so that there's a single API for any other service talking to it to help distribute the traffic to the actual services that need that. And then you realize you probably need an outbound proxy as well to ensure that when you're talking to external, like dependencies, maybe you have certain vendors that you're using for, various different, aspects of your business. So now you have this proxy there, and then someone adds a few new features that all depend on that very first new feature, that was added, and your microservices just continue to grow and grow. And you end up with this mesh. You end up with this huge interdependent set of services. And what do you do now? What do you do? How do you figure out how to measure this? How do you figure out how to measure whether or not this very complex system is actually doing what it's supposed to be doing? Each of these services here, each of these boxes marked as new feature, or the app, or the database, or the proxies, or the load balancer, you might be able to answer individually, what are these things doing and how are they behaving in and of themselves? But as this entire system also represents a single service, albeit one made up of many different components, how do you measure how this service as a whole is doing? So you start to think about it and you're like, cool, we need some telemetry. So we add logging. So this lets you know what individual binaries actually running are currently doing, what kind of errors are they outputting, what kind of successes are they outputting, but that's not quite enough. So you add metrics. Now you have some kind of time series available to you that lets you know exactly what your error rates look like over time, or what your success rates look like over time. And that's all good and well, but you really want to live in the future. You want to live in the present. And so you add tracing. And this is awesome because now tracing gives you a better view of how these services all interact with each other. They may even help you actually find dependencies that you didn't even realize existed. And so this is awesome. Now you have logging and you have metrics and you have traces and you have so much data, but what do you actually do with any of this? How do you use all this data to tell you how is this service as a whole, this multi-component service, how is it performing for its users? How can you possibly get there from all this data? So the answer is what I've dubbed the reliability stack. So the reliability stack has a few components, and at the bottom you have SLIs, or service level indicators. A service level indicator is just a measurement of how your service is performing from your user's perspective. How is it operating? How performant is it currently being? And the really important part here is it has to be from your user's perspective. I don't care how many metrics you have that say everything is great, what your uptime looks like. I don't care if you don't have any errors in your logs. If your service is not doing what its users need it to do, it's not being reliable. So you need to make sure you're developing measurements, such as service level indicators, that take their perspective into account. It's your users that matter most. And because of this, good service level indicators are often not a single time series metric from a single service, because that probably doesn't encompass the entire user journey. A good SLI is often an aggregate or a combination of data that you're able to grab from your logging and your tracing and your metrics. It doesn't always have to include all three, of course, but the point is you need to be taking a step back and ensuring that whatever measurement you're using here has a holistic, all-encompassing view of what your users actually expect of you. Next, on the reliability stack, we have SLOs, or service level objectives. So a service level objective is just a target. It's a target percentage for how often you want your SLI to be good. If a service level indicator tells you something like, yes, we're currently operating well enough for our users, or no, we're currently not operating well enough for our users, an SLO is just a ratio for how often you want that to be true or how often it needs to be true. And with SLOs, this is also where you can often bring in thresholds. So you can say things like, the 95th percentile of all requests need to be responded to correctly within 200 milliseconds, whereas perhaps, if you don't want to deal with the problems of a long tail, you can cut things off at the 99th percentile and say those have to complete within 500 milliseconds, something along those lines. These are very kind of generic examples, but the other thing that SLOs give you by being able to choose this kind of target percentage, they also give you the ability to admit 100% is impossible. We're never going to always be perfect for our users. That is simply not possible. No system on the planet is ever 100% reliable. Other engineering disciplines have known this for decades. Things fail. They will always fail. And you just need to ensure they don't fail too often. But not only is 100% impossible, trying to get as close to 100% as you can is just way too expensive. You really need to ask yourself, does this service really need to be 99.999% available or reliable? Something like 5 nines, that equals less than a second of unreliability per day. That's very difficult to achieve, and essentially no one ever does. So use your SLOs to set reasonable targets. Next in the reliability stack, we have error budgets. And error budgets are simply just a way of thinking about your service level objective over time. It's one thing to be able to say, this is how we're operating right now. We're meeting our SLO right now. We met our SLO last hour. But it's a different thing to be able to say, how have we performed over the last week, the last month, the last quarter, even the last year? And error budgets, the error budget data that's kind of output at the end of this reliability stack as I'm explaining it. That's really what this talk is about. You start with service level indicators. You start with a measurement from your user's perspective. You set a target for how often you want that measurement to tell you that things are currently good. And then use error budgets to give you a value that tells you how have things operated over a window of time. And not only do error budgets give you a more holistic view of how you've operated over a certain window of time, they also give you a way to translate some of this data into a more narrative form, something that humans can more easily process in their head. Because although we may all know math and we may all understand that something like a 99.9% objective means we have a 0.1% budget, 0.1% time that we acknowledge we may not be acting reliably enough, you can also, using error budgets, convert this into different data, different language. You can say something like 0.1% budget means we have 43.2 acceptable minutes of bad time every 30 days. This is something that's just easier for humans to wrap their heads around. So at the end of the day, the reliability stack, it helps you measure services, even if they're multi-component, as opposed to just looking at a single running binary or something along those lines. And the primary goal here, or one of the motivating factors, is that your service only has one job, and that's to do what the users of your service need it to do. That's what reliability really means. People often conflate reliability with things like availability or uptime, but even things like error rates. None of that matters, however, because you can be returning responses that are perfect and are not reporting any errors and are have very low latency, and you can be doing all that and still not be returning the data that your users actually need. And that's the most important part. That's what reliability is. Is your service doing what you need it to be doing? But you don't need your service to be doing what it needs to be doing too often. Because when you're focused on being reliable too often, you're spending too many resources. It's simply too expensive, not to mention simply impossible. And what's really cool about this entire approach, about service level objective-based approaches, is you end up with many happier people. First off, you end up with happier users. Your users are going to be happier because at the very base of all this is you are now measuring things from their perspective. And therefore, hopefully, if you're making the right decisions with your measurements from their perspective, they're going to be happier because you notice when things are wrong for them. You're going to end up with happier engineers because once you're measuring things from this approach, you know what actually requires immediate action. You no longer have to page at 3 a.m. if the error rate between your web app and your database is very high, if you know that that error rate doesn't actually correspond to a worse user experience. So now you can reduce your general pager load by ensuring you're only interrupting people when they really need to be. In the situation I just described, where you may have a high error rate between the web app and the database, yet the users aren't impacted, I'm not in any way saying you shouldn't go investigate that later. Just saying it's probably not the kind of thing that needs to wake someone up on the weekend. You're going to have happier product teams. SLIs are really just user journeys. And chances are your product teams have documents literally titled user journeys for your service, the things explaining what the service is supposed to be doing. So your product teams are going to be happier because you're measuring the exact things that they designed the service to do. And you'll probably end up with a happier business as well, because once you're focusing on the users and you have happier engineers and happier product teams, chances are this is going to be good for your bottom line as well. Okay, so now we've kind of outlined and discussed what service level objectives are and what all their components are. So what do we do now? So the classic version of how to use error budgets, as described in the original Google SRE book, is, well, if you have error budget remaining, if you've not yet run over the percent of failure that you have acknowledged you're allowed to have, then you can ship features. The idea here is you can make changes to your system. You can push out new features, you can push out new releases, no problem. And on the inverse, if you have ran out of your error budget, then you say, stop, no more features. We're not shipping anything. We need to focus on the reliability of our service. And I think, unfortunately, this isn't great. This is pretty outdated. Site reliability engineering and this concept is, 15, 16, 17 years old now, and it's just not the best approach. There's so much more that you can do with your error budget data. So the rest of this talk is going to be focused on a list of things that we can do with SLO data. What can you actually do with your error budgets that's better than just figuring out whether or not you can release or not? It turned out just a second ago was probably being a little bit too harsh, because the first thing you can do is, in fact, maintain a balance between shipping new features and focusing on reliability efforts. This classic example that we're going to return to again right here, it's not that it's wrong. It's just that it's not the only thing you can do. It's absolutely true that you can use your error budgets to tell you whether or not you should be making major changes to your service in the terms of introducing brand new stuff, or whether or not what you should be shipping instead is things that are paying down technical debt or things that are otherwise making your service more reliable. So again, there's nothing strictly wrong with this, and you just need to make sure that you realize that there's some potential downsides to using error budgets in only this way. One of the primary things I've seen over the years is that very often you can end up with a situation where you end up with this backlog and you end up with a bunch of back pressure. So you run out of error budget and you say, we're not shipping any new features, and suddenly you just halt that. In the meantime, the development teams and the product teams, they're still working on their feature work because that's what they're paid to do. And so they have 20, 30, 40 PRs lined up, all ready to go. And suddenly you're back with an error budget because enough time has passed and all those features ship at the same time, all these new changes ship at the same time, and all these changes at once, because remember, changes is generally what cause problems for computer services. All these changes go out all at the same time, and suddenly you blow through your error budget within minutes, and then suddenly you're right back to square one. You are now saying, we're no longer shipping features, we're focusing on reliability, whatever that might mean in this example. And this process repeats itself over and over and over again. A better way to view this, instead of thinking of this as a mandate, as a rule, ask yourself, okay, we're out of error budget. We think our SLO target is reasonable. We think our SLI is also reasonable and is measuring things from our user perspective. Should we ship or not? That's a better way to view this. Don't say out of error budget, no features. Say out of error budget, should this particular change go out or not? The second thing that you can do is you can just determine the focus of your general project work. So the first thing I want to mention here is that reliability improvements are features. This is one of the reasons I don't love the semantics, the linguistics of out of error budget, don't ship features, have error budget, sorry, the inverse, have error budget, ship features, don't have error budget, focus on reliability, is because, well, reliability is a feature. So I don't love that language there. Just think about things in a slightly different manner. Think about, should we be doing this or should we not? Just like we were just talking about whether or not you're shipping quote unquote features or not. The idea is really just use this data to have better discussions. Think about what you're doing. But the second important part here is that not everyone fits into this paradigm. Not everyone owns the code for the services that they run in the first place. So the concept of don't ship features is not even relevant at all. I mean, sure, you may be able to make some changes to your open source software in one way or another, but you think about things like your databases and your caches, and you might be employing Envoy and Kubernetes, and you may have an Elk stack for your logging, you may be using Prometheus for your metrics collection. For all these things, what does it actually mean to not ship features? Probably not very much. But what you can do is focus on how to make those things more reliable. How can you focus your project work? And the other thing I want to mention here is that updating or improving your SLIs or SLOs is project work in and of itself. You're not ever going to have perfect measurements. You're not ever going to have perfect targets. As you'll remember, nothing is ever 100%. Nothing's ever 100% perfect. And that means your SLIs and your SLOs will never be perfect either. They're going to have to move around. And this is a great example of, if you've burned through your error budget, perhaps you want to focus on that. So an example of how this might work, perhaps you have a weekly meeting, just a team sync, and part of what you do during that meeting is you look at your error budget and you realize suddenly, oh crap, we've been burning through a lot of it recently. But all of our users have been happy. as far as we know, and then maybe you even reach out. Maybe you're an internal infrastructure team and you provide the database platform that the rest of your company uses, and you go ask those engineers, hey, from our end, it's looked like things have been kind of unreliable. We're burning a lot of error budget. But then these other teams that depend on you say, nah, like, you're fine, like, it's good. Well, then maybe what you do with that data is you assign someone for the next sprint to go update your SLI or update your SLO target. Maybe you're not measuring things correctly. The third thing you can do with error budget data is to examine your risk factors. So here the idea is that error budgets, as opposed to other methods of trying to measure reliability of a service, they give you insight into how things are operating even over very short windows of time. So the idea here is that you may not hit a point of unreliability that previously with other methods would have triggered a page, but you can still have these periods where you're not operating as well as you thought you were. Perhaps when you release, things aren't running great. Perhaps DDoS attacks, which you think your CDN is mitigating very quickly for you, are actually impacting you more than you realize. Maybe upgrade periods, you're going from Cube 1.16 to 1.17, and you're doing this across all your clusters, and to you it feels like things are great, but maybe this is actually causing more of a problem than you realize. Error budgets help you identify these kind of things. So an example here is, let's say you have a large web-facing application and it runs in 50 different pods across several different Cube clusters. And when you do this release, you try to do it carefully. You do it in some kind of rolling manner. The problem is, even though the unreliability that you incur during these releases is not noticeable enough to the point that users are actually complaining to you, there is still some unreliability happening. While these pods are rolling, there's elevated error rates, there are people getting logged out of your website and having to log back in, whatever it may be. And via traditional monitoring, you may never actually find out about this because it's not quite bad enough for anyone to actually complain. However, you're still incurring a certain amount of debt here. You're still incurring, let's say, 5 minutes for every release where you're not operating well enough. That might not be enough for users to complain, but that 5 minutes added on to a separate outage might make it terrible. So what error budgets do is they let you capture these tiny little periods of time. They let you say, okay, even though this wasn't sustained for 5 minutes straight and therefore we didn't trigger a page, they let you look at something and say, okay, cool, our errors did in fact increase during this time period. Our user experience degraded during this time period. So error budgets give you a better way to measure this and give you a better way to be proactive about fixing some of this. Although you never want to be too reliable because you'll just incur too many expenses to try to be too reliable all the time. There's also nothing wrong with ensuring you're being more reliable than you would otherwise, so that when you do have a true failure or a black swan event, that you're able to more easily handle that. So the next thing you can do with error budgets is you can justify or delay some kind of experimentation or chaos engineering, anything that changes your service just for change's sake. The idea here is that to understand your systems, you need to know how they adapt and how they respond to different situations. And we can't get into all the details of what experimentation and chaos engineering really means, and they are kind of separate concepts, but the point is that you need to make changes to your service. You need to introduce different kinds of data or different traffic patterns to understand how they would operate if those traffic patterns or that kind of data was the reality. However, this is an easy way to ensure that your services are going to act unreliably for you. Changes are generally what induce periods of unreliability. And what error budgets do is they give you a good data point to figure out when it's reasonable or not to perform these sorts of things. Because if you have a bunch of error budget remaining, you know you've been very, very reliable over whatever your window of time might be. And this means your users are probably happy. And that means that if things become unreliable for a bit due to your experimentation, then it's probably fine as long as you can roll back quick enough. But if you've been very unreliable, perhaps you should just wait. And the other thing that this lets you do is it really lets you figure out where on the curve, where on the delta of change do things start to degrade for you. So examples here, things like, do you just want to try a new algorithm of some sort? Do you want to try a new garbage collection method? Do you want to change your cache retention configuration? You might want to try any of these things. And you have no idea what that would actually look like unless you did it in production. Use error budgets to tell you when you can or cannot do these sorts of things. So an example here is you have a Java app that's been around for quite a while, and therefore it uses the old default. You've heard that, the garbage first garbage collection method is actually supposed to be a little bit more performant. It's supposed to be an improvement, especially for the way your application has been written. But you've never had a time to check this out. Just a single flag change to the JVM wouldn't be too difficult to test. But when do you do this? When do you find out? Does G1GC really give us better performance than CMS? Well, this is an example of where error budgets come into play. Your error budget can tell you, yes, try this out now, versus actually maybe hold off. Maybe we need to wait a bit. And very similar, kind of related to experimentation, is you can use your error budgets to schedule load tests, stress tests, or various black hole exercises. And the idea here is that these are very similar to experiments, but they often have a more concrete goal. Whereas an experiment is what will happen here? Something like this is very concrete. Where do we break? When do we break? And oftentimes experiments can be performed by a single team, but things like load tests or stress tests often require the coordination across many different teams. And this is a good example of why you need SLOs for any kind of multi-component service. Even if individual teams responsible for individual microservices understand how well they're running, it's very difficult to understand how a multi-component service is running without service level objectives for the entire service. And one of the best ways you can figure out what those objectives should be is by testing them. And this, just like we talked about during the, about running experiments, is really lets you help understand where on the curve do you break. So you have a reasonable SLO target. You want to be reliable 99% of the time, but when does that change? What traffic level, for example, if you're doing some kind of load test, you can start ramping up traffic. You normally get 300,000 requests a second. And as you ramp up your experiment at 350,000 requests a second, you realize your performance starts to degrade. And maybe at 400,000 requests per second, you realize you're really starting to break. And about 450,000 requests per second, you actually crash and you go down entirely. And this lets you kind of understand what scale you're currently dealing with. How well are you currently operating, and what kind of traffic can you take on, or what number of errors can you currently incur? You can use your error budgets to not just plan about when you need to perform these sorts of exercises, but they help you understand when do things actually start head south. So an example of using these kind of exercises is, let's say you have a service, a large multi-component service that has always ran in two different data centers. You started off in one, and as you grew, you realized you needed some kind of redundancy. You needed, extra resources. So you spun up things in a separate data center, and things have been running that way for several years now. And you've realized now you don't actually know what would happen if one of those data centers just went away. And this is totally possible. It could be a network failure. It could be a power failure. There's a bunch of different scenarios that we could come up with. It could be a bad, routing table update. But the point is, you've been running so long in this kind of distributed setup, you don't know what would actually happen if one of your data centers went away. So you've scheduled this for next week. You spent months planning it, and everyone's really on board, and you're so excited to turn off one of your data centers, even if it's just from a network connectivity standpoint. But now you need to decide, is this reasonable? Should we be doing this right now? And this is where error budgets come in. They can tell you, yes, you can do it, or no, you shouldn't. And in this example, let's say just last week you had a terrible outage, some DDoS attack or some other upstream network problem. It may not have even been your fault, led you to be unreliable from the perspective of your users. Now you can say, well, look, we've burned through all of our error budget. Maybe we don't experiment right now. You can say, yes, we still want to find out when do things go wrong. We still want to find out what happens if we turn off one of our data centers, but maybe we wait a few more weeks. Let's wait until we've been reliable for our users for long enough that we can do this reasonably. The sixth thing you can do is just turn stuff off. So this is one of my favorite examples to talk about because it's something I actually experienced while I was at Google. There's a service at Google called Chubby. So Chubby is a log serve. It basically provides services with a way to gather very small bits of data, either upon startup or when performing things like leader elections. It's just a service that holds little bits of data essentially in files that a service can go out and grab and see what what the current status of things might be. And Chubby exists in a few different scopes. There's regional Chubby, which runs within a single Google region, and there is global Chubby. And global Chubby runs, as you might expect, globally. And it's very heavily documented that no one should depend on global Chubby. It's just there to make people's lives easier. It's just there as a nice to have. Do not have a hard dependency on global Chubby. You are, however, allowed to depend on local Chubby, on these regional Chubbies. Now, Chubby is a very old service. It's not overly complicated. It's been very well architected, and it generally runs very, very well, very stably. Very few changes are ever introduced to Chubby today. So at the end of every quarter, Chubby SRE, we're always able to look back and say, look, we were 100% this quarter technically, so we have error budget remaining. And what they would do is, well, they would purposely burn their error budget. Now, they would inform people. You'd get an email saying, we're going to turn Chubby off at 3 p.m. Eastern time on this Thursday, something along those lines. But they would, in fact, just turn things off. And what happened almost every single time is someone who thought they didn't have a hard dependency on Chubby would discover that they, in fact, did. Some service would crash. Some service would degrade its performance terribly. And by turning things off on purpose, by burning their error budget on purpose, what the Chubby team did was it allowed these other teams to learn about their dependency problems. By not being more reliable than they were promising to be, by not being more reliable than what their SLO target was, they're actually giving people a better understanding about the reliability of their own service. The seventh thing you can do with your error budget data is nothing. I think this is actually a very important one and one that people often skip over. Sometimes your measurements are wrong. Sometimes when you burn through your error budget, you realize it's because there was a problem with your calculation, or that you've set a bad target, or that your monitoring systems were broken and not actually your service. And sometimes it's just because you already know you have a problem, and maybe this problem will take a long time to fix. So it might be a quarter where you know you're out of error budget and you know that isn't good, and you know your users are not having a good time. Yet you also know that, well, there's simply nothing we can do right now. So you can ignore your error budget numbers. And the important takeaway from this kind of approach is that you got to remember that SLOs, the whole SLO approach, whether it's SLIs, SLOs, or error budgets, the point is to provide you with better data to have better discussions. They're data, they're not mandates. So an example of this is, performance of your cluster has been terrible. You've just overloaded it and you didn't have the right provisioning schedule in place. You know you need new hardware. Let's say it's something like your distributed database that runs on 15 different physical servers. You know they all need SSDs. But the timeline for one, getting the financial approval for these new SSDs, the actual hardware ordering and having them delivered to your data centers and being able to then install them all, because you can only take down one server at a time, let's say, and then your recovery period once you bring the server back in might be on the order of a day or two, something along those lines. The point is we can very easily imagine a situation where it could take weeks, if not months, to actually perform this upgrade, from noticing you need it to ordering the hardware, to first getting approval for it and then ordering the hardware and getting all the upgrades in place. This is an example of where you just don't have to do anything, even if your error budget data is pretty bad. Now, once this solution is in place, then you need to look at your error budget in a slightly different manner. But this is an example of just, again, these are not mandates, it's data. And sometimes the data says it's fine, we're already working on it. One of the most important things that error budgets give you, more important, I think, than almost everything that we've talked about previously, is they give you a better way to report on the reliability of your service. So how do people do reliability reporting today? So generally, the way people report reliability over time is they start with something like incident counting. How many incidents did we have this quarter? How many times were people paged, or how many times did we have to update our public status page? And this isn't great. And after that, people generally move on to mean time to something. They realize just counting a number of incidents doesn't really do much for you. So instead, they start counting how long these individual incidents are on some kind of mean, some kind of average. But these aren't really great approaches, and let's talk about why. So the problem with counting incidents is, well, let's just give you a little example here. Let's say in Q1 you had 20 incidents, and in Q2 you had 10 incidents. But in Q1, the incidents added up to 120 minutes of unreliability. That's how long your users, your customers, were upset with how well you were currently operating. But in Q2, those 10 incidents added up to 150 minutes of unreliability. So as you can see, counting incidents doesn't really work well because Q1 had more incidents, but Q2 was actually a worse user experience for people. And once people realize this is when they move on to MTTX. What is MTTX? Well, mean time to MTTR is the most common, and even that, it can stand for mean time to resolution or remediation or recovery or response or a bunch of other different things. But these MTT acronyms can also stand for mean time to detection, mean time to failure, mean time to engagement. There's a ton of them. I've documented 15 or 20 that I know of that people actually use, like out in the wild. And the problem with MTTX is, let's just go back to our original example. In Q1, you had 20 incidents that totaled 120 minutes of unreliability. In Q2, you had 10 incidents totaling 150 minutes of unreliability. So if you average these things for Q1, each incident had a 6-minute mean time. And in Q2, the incidents add up to 15 minutes each. And while this does in fact tell you that Q2 is worse than Q1, which the counting by incidents method didn't do, this implies that Q2 was more than 2 times as bad as Q1, which also just isn't true. So what do you do once you realize that trying to measure mean time to anything doesn't really work either? Well, that's where error budgets come in. Error budgets by default, by their very essence, they give you a way to report how your service has operated over a time period. Per day, per week, per month, per quarter, per year. This is what error budgets do. This is their entire thing. How reliable have you been over X period of time? And finally, I want to talk about having better conversations. And this is, I say here, maybe the most important, but no, this is the most important because it's all we've actually been talking about. Everything on this list, the previous 8 different examples, they're just that, they're just examples. And every single one of them, what they're really talking about is, let's gather better data and use that data to make better decisions. Whether or not those conversations are about should we release or not, whether or not those conversations are about should we experiment right now, whether or not those conversations about do we take any action at all or not, the point is, a service level objective based approach to reliability gives you better data to have these better conversations, and better conversations lead to better decisions. Remember that at the end of the day, everything is about the humans, whether you're talking about users, the operators, the engineers, the production team, or even just those involved with the business. Everything is about humans and having better data-driven decisions. So thanks for joining me, everyone. I want to mention I wrote a book about all this. You can get much more in depth about both how to measure error budgets and how to use them correctly. It's called Implementing Service Level Objectives, put out by O'Reilly Media earlier this year. Please go check it out. I'm immensely proud of it. And thank you very much. I'll see you in the Q&A in just a few moments.